Yes, all right. It is always perilous being the first talk after lunch. So thank you for trusting your after lunch talk with me. Let's get started. So like she said, my name is Clair Sullivan. Here's my email address, how to contact me. Before we begin in earnest, I will tell you, don't worry about taking those photos of the slides. You can download them here at this GitHub repository. And in fact, it has all of the code that is used to generate what you're going to see today. So that's the thing that you should take the photo of, if anything. Okay, so today we are going to talk about all kinds of fun stuff like graphs. Who here uses graphs on a daily basis? Okay, we're going to talk about knowledge. We're talking about knowledge and graphs. So we're going to talk about knowledge graphs. And we're going to talk about entities. We'll talk about the terminology, what I mean when I say each of those things, and how they apply to this world of Gen AI that we find ourselves in today. Then we're going to talk about entity resolution. We can't talk about entity resolved knowledge graphs without entity resolution. We'll talk about what it is and why it's hard. How not to do entity resolution. I'll show you a way that I did it and used that to create a knowledge graph for retrieval-augmented generation. Who here is doing RAG in their Gen AI pipelines? Good. And then I'm going to show a worked example of why it is that you want to be doing RAG with entity-resolved knowledge graphs and give some conclusions. So let's start with definition. Some definitions. Graphs. Things connected to other things through some sort of relationships. We call those things nodes or vertices. We call the stuff connecting them relationships or edges. A knowledge graph, though, is kind of a special subset of a graph. A knowledge graph is where we have ideas connecting to other ideas. There's a famous graph database company out there that said that all graphs are knowledge graphs, whether you agree or disagree with that statement. The idea here is that we are converting concepts into a graph. Entity resolution is how do we know that those concepts or nodes are unique within the graph or within our data. And then an entity resolved knowledge graph would be a graph whereby we know that each of those nodes are unique. And we're going to see each of those play out today. All right, let's talk about what is an entity, though. You're going to see this term come up a lot, and I think it's pretty overloaded. An entity is basically just a distinct physical thing. And when we talk about entities, we're usually talking about people, places, organizations, even objects, like think vessels or cars, like ships and stuff like that. And as data scientists, we grow up in a SQL world. We cut our teeth on rows and columns and tables. So you could even think of an entity as a row within a table if you wanted to. They usually are defined by some distinct characteristics. So if we're talking about people, those might be names or other different characteristics. Maybe if you're talking about products within your company, you've got some sort of product ID number. But they can have lots of distinguishing characteristics. And turns out not all of them are as valuable as the others. We'll get into that, though. But I want to start with a hypothetical scenario. Now, let's say you're a data scientist. Let's say you're working in sales or marketing or something like this. And you have these two scenarios. One of them is you have 5 different people making a single transaction. The other one is I have a single person making 5 transactions. Now those are going to matter that you can tell the difference between the two, right? It's going to matter for things like calculation of customer lifetime value, how many unique customers do you have, but it gets to like this really fundamental thing that we do in data science all the time, which is just counting. The very first thing you learn to do in SQL, select count star, right? What if you can't actually count your entities within your data? You can't count your customers, you can't count your users, something like that. Well, that would be bad. So if you cannot count, you cannot predict. If you cannot count, you cannot quantify. ARR, what does ARR mean if I don't know how many customers I have? That's bad. Okay. So by having a good understanding of who our entities are, it enables us to go to our CEOs and give them good news or bad news, okay? Oh, wow, look, our number of users is up. You sure about that? It tells us red light or green light. It tells us whether or not somebody is marketable, whether they're a threat or benign. These are all really crucial things to be able to tell your business. And if you can't count, you can't do it. So let's go through a little bit of an example. Oh, this is my hot take, by the way. Regex is not the answer. I'll show you why here. We're going to go through a bunch of really good examples. And I should put like some caveats or some understatements to this as well. Regex is not the answer. Edit distances are not the answer, meaning if I change a character here or there, that's not going to solve this for you. These are, we all start by trying this, right? We all say, oh, well, that character, that name is one character off. It's a typo. We're going to call that the same person. Okay, that's great and all, but to do this properly, regex is not going to get you there. Edit distances aren't going to get you there. Clustering is not going to get you there. And so when we think about entity resolution, we really need to come up with a better way beyond these very basic techniques to do it. Why? Well, names are complicated. So here is one name that is represented many different ways, and there's in the same database. Now, I started with Jonathan Edwards Smith. Okay, now, how many different ways can you spell Jonathan? And not even counting the typos that could be thrown in there. And then Jonathan has many different nicknames. That could be John, Johnny, Jack. Don't ask me why Jack is a nickname for John. If somebody can explain that to me, I'd love to know. Edward could be Ed, Eddie, Ted, Ned, any number of different. Nate is another common nickname in there. So this is that same name represented a whole ton of ways. You tell me that you can get all of those with just regex. Sure, you could create a dictionary of common nicknames for each of those names. Still not going to get you there, though. And by the way, what happens when you're talking about other character sets, other languages, other cultures? That's a problem. Okay, addresses, even worse, even more complicated. So this is 123 Main Street, apartment 1A, Las Vegas. Well, I didn't even add on the extra 4 digits onto Las Vegas. And look at all of these different permutations I got. Okay, and there's probably way more. And you'll look at that and you'll be like, wait, what's the difference between these two? Well, some of them, have hash signs, the number sign. Some of them have periods for their abbreviations. Some of them include street, some of them don't. Street might be abbreviated, it might not be. This is complicated, and I'm only talking about a very nicely formatted address. Those get a lot worse if you deal with this type of data for real, okay? So you have to be able to handle all of these things. Regex is, I don't even want to think about the regex that's going to get you there just for US-based addresses, assuming they're nicely formatted, which for those of you who deal with customer data, you know that that's just not the case. All right, what happens if there are different character sets, different cultures? Addresses are actually remarkably hard to parse. There are whole libraries out there for dealing with addresses, and it's unpleasant to try and do this yourself. Look at these cultural variations that we're talking about. Different countries represent their addresses different ways, if you even get a good address. I read something that it's like single-digit percentage in certain countries that you actually will get like a postal number and a street and a city. All right, so if you're going to assume that you can do your entity resolution just by matching addresses, that ain't going to happen. Okay, so all of this is taking us to a place that if we accept that RAG is important for Gen AI, the ability of your RAG to get the correct answer is only as good as your entity resolution. Now, when we do RAG traditionally, we talk about vector databases and we talk about chunking text and all of this stuff. But ultimately, yeah, we're going to do a cosine similarity on some vector embeddings, and that's all well and good. But ultimately, if you take a step back and think about what was the term? It wasn't classical machine learning. What did we call it, Natalia? Vintage natural language processing. Okay, so if any of you who attended any of my previous talks for ODSC, creating knowledge graphs with vintage natural language processing, that was not fun, right? And so Gen AI happens, and now we can create knowledge graphs a lot easier. But it still comes back to those vintage problems, things like named entity resolution, detecting triples, subject, verb, object, or subject, predicate, object triples. It's still a hard problem. It only gets worse if you are not able to resolve the entities in your graph. So whether they say, I am Claire Sullivan in the graph, Claire, Dr. Claire Sullivan, Dr. Sullivan, doesn't matter. It's all the same person. But if those show up as different nodes in the graph, my ability to use the graph for RAG in GraphRag is greatly diminished. So let's go through an example here, and I'm going back to my Jonathan Smith example. I didn't include the middle names this time. But I have 4 different records here. Okay, so I have Jonathan Smith, Jack Smith, John Smith, and Dr. J. Smith. How many entities do I have here? Anyone want to shout out a guess? 2. I heard a 2. Why? Birthdays. I do love the birthday one. Yeah, birthdays are, this is a case where you have a characteristic that is a little bit more defining than another characteristic. Obviously, name here is not getting you there. Address is not getting you there either, because I have my 2 nodes on the left. I've got Jonathan Smith and John Smith, different birthdays but same address. So this could be a case where we have like a father-son relationship, right? And they have the same address. You even see families sharing the same email address. So if you think email address is a good discriminator, it's not. So yeah, so birthday is a really strong indicator. Let's look at what if I wanted to ask this data a question. Tell me about John Smith. What's going to happen to your AI if you do that? Nothing good. Unhappy AI bot, right? But it's because your Gen AI application did not understand how these entities resolved with each other. So for instance, you see the cross that's going in the middle here. I've got the upper left and the lower right are the same person, and we figured that out based on birthday, and then the bottom left and the upper right, John Smith and Jack Smith are the same person, we figured out based on birthday. We could, eventually figure out parents of relationships, but the bottom line here is we got it based on birthday, but are we going to get that on regex? Dates are a little easier to parse, but I think I tried to make the point here that all 4 of these dates are represented in a different format. I am going to wager a guess, raise your hand if this is true, and you work in a place where you have dates in your data and they're all in different formats, or you have a lot of different formats. Anybody deal with that problem? Yeah, I hate that, right? It's just annoying. And yet it's very, very, very common. Addresses, who's got addresses in different formats? Yeah, very, very, very common. How can we deal with this? How can we give our Gen AI applications the best chance with their RAG to get the correct answer if that's what our data looks like? Here's another one that's really hard, ownership. So if we're talking organizations as our entity, I have 5 grocery stores up here. One of them owns all of them. So the outer ring ones, City Market, Harris Teeter, et cetera, those are all owned by Kroger. But what if you're looking in your database and you said, I'm selling to, Smith's? Who are you selling to? What is your revenue relationship with Kroger if you're selling to Smith's, if you don't understand that there is a relationship between Smith's and Kroger's? So when we're talking about entity resolution, going beyond just the basics of people, ownership can be really complicated, okay? And I mean, I had to Google this, or, Wikipedia was my source of knowledge here. I didn't realize that Kroger owned all of these things, but as you are trying to present your data to your C-suite, if you can't represent this because you don't understand that they're all the same entity, you have a problem. So let's actually do an example here. And I went and I got some publicly available data, 3 different data sets that I thought were kind of fun. One is called SafeGraph. SafeGraph is just a publicly available data set of places and organizations and things like that. I chose the Las Vegas area just because it's nice, confined geospace. Then I looked at the Department of Labor wage and hour compliance data. So this is how many violations did a company have on wage and labor laws? And then I also went and got some data on the Payroll Protection Program, PPP loans. Now, what the PPP loans were, for those of you who don't remember, was right when the pandemic hit, the government said, okay, well, we need to have a way to help people pay their folk through this, this unprecedented time. So we're going to give out loans. So you can actually download a data set on who got what type of loans, and I'm looking at loans over 150K. Then entity resolution. I chose to try this package called Sensing. Sensing, you can just go get it off of their GitHub site. It's just a nice Python SDK for doing some commercial level entity resolution. I'll show some examples of what it looks like when we get a little further into the talk here. The nice thing that I like about Sensing, it doesn't require any training. I've used other entity resolution things where you really have to train it up and have a lot of human involvement, steering it and doing multiple rounds of training. Sensing doesn't need that, so this was nice and simple and low weight for me. The other thing that Sensing does really well is it works with all the character sets and it does address parsing. So, if you have complicated addresses, it can figure it out. If you've got, different like Cyrillic characters or different Asian language characters or whatever, it can handle that. Then I also used LangChain, just, quick, simple, easy. And I wanted to compare what happened if I did RAG two different ways. One of them was I was going to do RAG just based on SQL tables, no entity resolution, but just kind of how most of our data looks. Anybody here like not work with SQL tables? Okay, you don't have to raise your hand. But the point being is that started simple. This is where we all start. And then I decided to try it doing with an entity resolved knowledge graph as my RAG. So I ran the data through Sensing, created a graph in Neo4j, and then I used that with LangChain to run Cypher queries against. So let's just talk really quick, and this is an eye chart. I don't expect you to be able to read it, but this is what the data looks like. So safe graph, just a whole bunch of entries on companies or locations. At the very bottom, you can see this is a pizza place in Las Vegas. Here's what the Department of Labor data set looks like. I've got business names in here. You'll notice that the addresses are, everything looks slightly different between like each of these data sets. And then I have the PPP loan data. I can see what was the loan amount. I can see like who the lender was, what the company was receiving it, things like that. And so I wanted to do things with this data, like ask, okay, were there companies that had a lot of DOL violations who got big PPP loans? Because, I don't know, maybe that's something that we care about. We want to make sure that companies who are getting these loans are, in compliance with Department of Labor regulations. So let's talk about how I did that with SQL. So I took those 3 data sets and I just loaded them into SQL. And I created just a little agent executor, which is like an ancient way to do this now, but like last week, it changes so fast. And I said, I looked at the data and there was this one that I came across called union cabs. So I find all references for union cabs. It said it only existed within the safe graph data SG, wasn't in the PPP data or the DOL labor. And I said, do they have any violations? And the answer was no, they don't have any violations according to these databases. I'm like, okay, cool, fine, but is that correct? So what I did then was I took that same data and I ran it through Sensing and put it into Neo4j and then created graph queries for it. And before we do that, let me just show you quickly what the data looks like coming out of Sensing. So this is just software runs on the command line. It's called G2 Explorer, and you can go look at your data here. So in this case, I'm looking at a company called Desert Springs Landscaping. And it just pulls up the record for Desert Springs. I can see that there are 2 data sources. So that's that middle column there with the orange font. I can see that Desert Springs Landscaping, and by the way, this is case sensitive. I can see that it exists both in SafeGraph and in PPP loans. let me show you here. There's this entity idea of 12093. I can use that to just kind of further drill into the data and see what can be seen. So here is giving me the actual detailed information on that 12093 record. And I can see what the PPP loan data record shows, and I can see what the SafeGraph record shows. But the interesting stuff is at the bottom. So this is Sensing detected possible relationships, and you can see here that these relationships are based on address. This is the text that's in green, or address and geolocation, or address and geolocation and phone. So maybe this is building in your mind that the more of these things that get matched, the more likely it is that it's the same entity. So Sensing considered these possible locations, and if you look at the names, it kind of makes sense, because if I'm a landscaping company, probably I need something like excavation. And so they run their own excavation company that's not named anything like Desert Springs. It's Harshman Excavating Corp. Okay, so I don't think anything in regex is going to tell you that those are the same companies. I see Desert Springs Renovations LLC, slightly similar to our original search term. But all of these are kind of starting to tell a story here. There's Oasis Spring Builders, Desert Springs Group. Okay, these are all companies that probably have the same ownership or something like that. And that's just a nice handy thing that Sensing does to tell you what's going on under the hood. I went and looked at another one of these, Desert Springs Pool and Spas, Inc. I can see that it's related to a bunch of things. It's got this disclosed relationship at the bottom of Blue Diamond Crossing. I was like, oh, what's that? Well, it turns out Blue Diamond Crossing is a strip mall in Las Vegas, and a whole bunch of places match based on that strip mall address. So that's all good, but how are we going to use this? Well, we're going to create a graph, okay? So we're going to take that Sensing data, and we're going to dump it into Neo4j. Now, we're going to have, this is something that I did that's a little different than maybe other content out there. I kept the original data, so I've got my SafeGraph entities, so that's every row in SafeGraph I consider an entity. I've got PPP entities and DOL entities, same thing. But then the beige nodes that you see there, those are the Sensing entity resolved entities, so cornerstone entities or core entities or whatever. But you could do this where you're only looking at the entities that, the individual entities and the resolved entities that Sensing said. But I decided to create a graph this way because I thought it might have the LLM being able to ask and answer some better questions based on the data. Try it out for yourself. Your mileage may vary. I'm going to go back to that Union Cab example. Remember, I wanted to know how many violations did Union Cab have? Well, it turns out that Sensing said there were actually 3 entities involved here. We had Union Cab Co., we have a NLV Cab Co., and we have Vegas Western Cab Inc. And Sensing was able to detect that these are all the same entity. And you can see blue is, I think, SafeGraph and DOL. Okay, so I've got SafeGraph entities, I've got Department of Labor entities, and they're all kind of resolving down into one of 3 companies that are probably the same company. So I said, tell me about Union Cab Company, and it comes up with a pretty detailed bit of information now. You remember when I asked that in SQL, it was like, oh, well, it only exists in this one data set. Well, it only existed as Union Cab within the SafeGraph data, but now we can see that there's other things like Western Cab Company, a NLV Cab Company. So automatically, we just got a lot better information, a lot more rich result returned to us by our LLM because we were using that entity's resolved knowledge graph. Next, how many violations have entities Union Cab Companies related to been involved in? And now it says 6. Well, that's a very different answer than what we had before, where it said there were no violations. Okay, so we got completely the wrong answer when going strictly with an unresolved SQL database, and we got the correct answer when going with the entity resolved knowledge graph. I hope that motivates to you the importance of doing entity resolution on your data, whether you want to represent it as a graph like I did, whether you want to represent it as a simpler graph, whether you want to just keep it in SQL. The bottom line here is that if you cannot count, if you do not know who your entities are, you will not get the correct answer. So, hopefully, at the end of this talk, you have seen that, first off, RAG is important. I know that's a tremendous surprise. Secondly, graph RAG is important. For those who are interested, I have a course coming out on graph RAG later this summer with LinkedIn Learning, so stay tuned on my LinkedIn page for that one. Next, doing entity resolution is hard, but it can be solved with the proper tooling. That proper tooling is not regex, it is not clustering, it's not character distances. You want to think about bringing proper tooling to bear when you're creating your entity resolved knowledge graphs. And graph RAG with ERKG is the importantest. So with that, I would like to say thank you. Again, here's my contact information, here's the repository, and I'm happy to take any questions.
Thank you. This was awesome.
Thank you.
A lot of the examples that you gave were from structured data. I know from being a vintage NLPer that unstructured data is going to present a lot more problems. Would you recommend the same approach? Would you recommend, I don't know, what to do when a lot of my data comes from unstructured?
Yeah, that's great.
Maybe all of it.
Yeah, so now we're getting into things like named entity resolution, right? And that's hard. So sensing is a nice tool for dealing with structured data. As you know, this is going to be 50 ways harder for unstructured. So yes, I wish I had a better answer for you.
You don't have the solution for me, like right here in this? Okay. We'll keep working.
Well,
but this was great to see it resolved and what you can really still do with it with natural language. That's awesome.
Yeah, because if you think about it, what are we doing when we're doing named entity resolution on unstructured text? We're coming up with those triples again, subject, verb, object, right? But when we do entity resolution, we're resolving on characteristics. Now, if you can start bringing characteristics into it, this node is, this named entity is Clair Sullivan, who has a social security number of 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know if that was enough numbers. So if you can start bringing characteristics into it, features, then you have an easier problem.
Great point. Okay, thank you.
Mm-hmm. Other questions? Yeah.
Thank you so much for a great talk. I thought the most interesting word in your presentation up on the slides was possible.
Possible.
Right, the idea that there's a possible relationship, which makes a triple turn into a quadruple, right? It's, you got the usual triple plus confidence, right?
Right.
How much do you think that's likely? It seems like it's the kind of thing that the machine learning models should be able to handle well, because they're all based on heuristics. Mm-hmm. But then we seem to fall back to what do we know, right? These things are true, and now you're doing analysis based on it. Have you done any work, or would you recommend that we look at things for thinking about these graphs probabilistically in terms of their relationship, saying this probably looks like this has I have a high degree of confidence or low degree or whatever, as opposed to I know?
I love that question. Thank you. Yes, I think that there is definitely a there. Have I personally done that? No, not yet, but that sounds like fun. And I think it's really important because data scientists, we're used to going to our management saying, here is the answer. I can put a little box around it. Some professor comes by and gives it a check mark, gives you an A, whatever. And now that we're in an LLM world, we're in a probabilistic world now. And so we can't just say, here is the answer. In this case, we could. I mean, I picked this demonstration, for a reason. But we have to understand that even every time you run the question, you might get a different answer. And what does that mean? So now we're getting into LLM evaluations, and that's a different talk. But yeah, I really do think we need to start thinking of our data in a more probabilistic sense. If our outputs are going to be more probabilistic, we need to understand the probabilistic nature of the inputs as well.
Thank you.
Maybe one, oh. Yep, we got one last one over here, and then then let's talk afterwards because my little timer just went off.
Yeah, thank you for the great talk. I was wondering, given like how many amazing things we can do with like current LLMs that are, based on vector representations, and maybe that might not be the best representations as you're suggesting using graphs. Do you think that the current math machinery like is readily available to like support fully built tools such as LLMs that are not based on vector representations?
Yeah, and you can do that right now. So you can do RAG with a vector, you can do RAG with a graph, you can do RAG with a hybrid approach. So all of those methods are out there right now. And I would encourage you to check out papers by Juan Cicada, who actually has done some really nice studies, reproducible research studies that show that graph RAG looks like right now it's more accurate than vector-based RAG. But if you could do both, I mean, let's do it. So,
Thanks.
Thank you.